Hi everyone! I'm going to show you guys how to do this summation problem, and I hope that it helps you, okay? Now, I particularly really like this summation problem. I think it's really fun because we get to practice a couple of laws that we should be a little bit familiar with. Alright, so without further ado, let's get started. So we have a summation here, and every time you have a summation problem, you want to figure out what are you summing up. Like, what is the summation in terms of? So let's look at our lower bound. It says I equals 0, and it's summing up something to the nth term. Therefore, we can conclude that this summation is in terms of I, because I is the thing that's changing. It's going to be I equals 0, 1, 2, 3, 4, 5 to the nth term. Alright, so we established that. Now we also have a little nifty law that says that if we have some operators inside of our summation, we can't really work with it. So we have to break up this summation into 3 separate summations. That's the only way we can work with it. So let's go ahead and do that. For each term, we're going to have our own little summation for it. Okay? So let's do that. And I'm actually just going to copy this. So we have 4i, that's our first term. There's our second term. And then finally we have our third term. Great. Oh my gosh, what's happening? There it goes. Alright, so now that we separated our terms into 3 separate summations, now we can play with them. Let's look at our first summation here. We have 4i inside of our summation. 4 is merely a number, it's a constant. And something cool is if we have a constant, we can just tack it on at the outset of our summation. So and then we'll have a multiple of 4 later on. So we move the 4 out because it's a constant. And remember, our summation is in terms of I, so I stays in the inside because it's something that's changing. That's our function. So now let's look at our second summation, 3/4 n. Now is 3/4 n, is this a function in terms of I, or is it just a constant? Well, are there any i's around here? Nope, I don't think so. So 3n is just actually a constant. Now don't be scared if you see like another variable. N is just a number. It's to the nth term. So n is just a number being multiplied by a number. Therefore, it's just a number. Okay? And since we're just multiplying by a constant, inside of our summation, we're going to be summing up ones. Now this is just a law, and if these laws don't really make sense to you, then please let me know. I can create sub-videos explaining these laws, but for the sake of time, I have to move forward, okay? Same principle applies for this one here. This is just a constant, so we're going to be moving it on the outside. Great. Okay, now that we have some summations, we can further break them down. Let's look at our first one here. We have 4 times the summation of I as I equals 0 to the nth term. Now every good computer scientist should know this formula. When you have a summation of I, when I equals 0 to the nth term, it's simply going to be n times n plus 1 all divided by 2. Now you can actually derive this yourself if you're kind of bored, and curious. It's a really cool proof. And just look it up and it should come up. It's by taking the numbers 1 through the nth term and then summing those up and then summing up the same numbers but backwards. And then, yeah, it's really cool. Check it out, alright? And then we're just going to be multiplying by a factor of 4. And then how about for this one here? Now, another summation law that we have is when we have the summation of 1, when I equals 0 to the nth term, it's going to be the upper bound, which is n, minus the lower bound, which is 0, plus 1. Okay? And this if you think about it intuitively, it's like the change of the nth term minus the initial, okay? And then we take that change and we have to add 1 because we're also summing up the first term as well. And then we're going to be multiplying that by our constant. Then same thing applies here. Take our upper bound minus lower bound plus 1. And then we're going to be multiplying by a factor of our constant again. Great. Now we have this crazy equation here. And from here now, it's just algebra, okay? So let's go ahead and simplify this. Hopefully I don't screw up my algebra somewhere. It's bound to happen. I'm so sorry if it does. 3/4. I'm going to do that. It's n plus 1 over 2. Alright, let's make a common denominator of 4. So, I have to multiply numerator by 2. Okay. And then this is going to be the same here. We want to multiply the numerator by 2 to get a common denominator of 4. And great, we're nearly there. Let's combine all of our like terms together. Okay, so here is our final answer. And let me check this. 3/4, 3/4. And, oh, see, I was like, oh, I didn't make any algebra mistakes. Let me double check. So 8, this is 11. 8 plus 3n plus 2n is not 11n. It's actually 13n. Alrighty, so yeah, that's our final answer. Hope you found this video helpful, and good luck.